Hello and welcome everybody. I am the Shy Hat and this is HackerFrogs After School. So welcome HackerFrogs. Alright, so today we're going to be concluding our study on SQL injection with TryHackMe. We're going to be finishing off the TryHackMe room that we started last week, and we're going to be covering two more types of SQL injection. But without further ado, let's jump into it. Okay, so this is web app hacking workshop number 6. And if you want to keep up, you definitely want to have completed the previous workshop, which basically has to do with completing the first half, or rather the first few tasks in this TryHackMe room right here. I will provide the link to that in the chat, just in case you don't have it. So let's do a little review. So this is the 6th Intro to Web App Hacking workshop. In the previous workshop, we learned about the following web app hacking concepts. So we talked about SQL injection. SQL injection vulnerabilities can lead to sensitive data exposure, admin account takeover, web server takeover, and more. We talked about in-band SQL injection. In-band SQL injection is SQL injection where the results of the injected query can be seen in the output of the web app. It is considered the easiest type of SQL injection to exploit. Error-based SQL injection is a type of in-band SQL injection where error messages from the database software return to the web app interface. And union-based SQL injection uses a SQL union operator with a select statement in order to output additional database information from the web app. So using this union select SQL injection, we can dump various information from the database, including the contents of tables. We talked about blind SQL injection. Blind SQL injection is SQL injection where the error messages resulting from improper SQL queries has been disabled, but the requests are going through nonetheless. So in blind SQL injection, you don't know whether or not your SQL injections are successful through the web app interface, but there are other ways of telling whether or not your SQL injection has gone through. To that point, authorization bypass is a type of blind SQL injection where insecurely written code allows the login of a user to a web app without the use of a proper username and/or password. So the most basic authorization bypass SQL command is this one right here, which lets us log in by making the SQL statement that lets us log in true. All right, so we're going to be continuing learning SQL with TryHackMe at the following URL, which I have provided in the chat, but if you don't have it, we're going to go back to that particular room, and I will paste the link in the chat for you once again. Okay, so once you are there, let's see, so split view, I'm going to terminate this so I can demonstrate to everybody how to start up the machine. So once we've come to this web page, we want to venture down to the task 5 header over here and then click on it. And then we want to click on the Start Machine button right here. So it's under task 5, and once you open that, the button that you want to push is this green one right here. So press that green button, and it's going to say starting your machine, please wait. If you do not see the browser pane split into 2, you want to go back up to the top of the page and click on this Show Split View button right here. So click on that, and it'll show you the initialization process for the virtual machine over here. So this might take somewhere in the neighborhood of a minute or two. But while we're waiting, let's ask everybody how they're doing today. So I know that our good friends Hachi and Ilhan Idris are in chat right now. Did you do anything fun over the weekend? Did you do any cybersecurity study or anything else? And did anybody here catch the there was a solar eclipse that happened, and I think some of the users in chat might have been able to see the solar eclipse today. In which case you would have seen that it became very dark around maybe 12 o'clock today. That would have been pretty fun. So this seems to have closed on me, but I'm going to open it back up. So once again, the task we're going to be working in is going to be task 7, I do believe. So once you've opened up your virtual machine on this page over here, we can close task 5, and then we can click on task 7 over here. Okay, so Hachi says the eclipse was blocked by the clouds earlier. I was so disappointed. I'm sad to hear that. Earlier today, I saw some footage that was being live streamed to the NASA YouTube channel, and it looked pretty good. Unfortunately, where I live, there was no solar eclipse because I was outside of the range of the solar eclipse, which was also kind of sad. But all right, so everybody, if your web page is loaded up, please type in chat ready to SQL and some smiley faces. And what was that? What was that frog emote? Frog emoji. I gotta look it up. So I would really like to know how to copy these emojis, just like that. All right, so once you've opened up your web page over here, what you want to do is you want to put this in its own web browser tab, and you can do that by clicking on this button right here. So in the middle of the screen, go down to the bottom, and there's a selection that says View in Full Screen. I'd like you to click on that, and that's going to put this in full screen. And then you can go back to the TryHackMe web page, and you can click on Exit Split View over here. Okay, great. Okay, so Hachi is ready to SQL. Good to hear, good to hear. All right, so that means after you've done that, you'll see that the SQL web page that we're going to be working with is in its own browser tab, and our TryHackMe web page is in its own browser tab, and that's what we want to do. So we're going to be learning about Boolean-based SQL injection. So Boolean-based sounds like it's some sort of soup, but I assure you that it is not. Let's take a look a little bit more about that. So we're talking about blind SQL injection, which is Boolean-based. Boolean-based SQL injection is a type of blind SQL injection where the only output that is returned after a SQL statement is whether the query returned true or false. So this is true or false SQL injection, basically. So the key to using Boolean-based SQL injection is the use of wildcard search queries to incrementally determine valid database contents. So Boolean-based SQL injection is a SQL injection attack where certain statements are confirmed true or false by the SQL system. We're going to be taking a look at the web app for this particular task, and it tells you whether or not something is true or false. In this case, whether or not something is taken. For example, a username. In doing so, this allows us to enumerate the database's structure and contents. So we're going to be using a union select SQL statement to determine whether or not the database is, the name of the database is something something, and incrementally we'll find out whether or not this is true or not. So Boolean SQL injection is heavily dependent on the like operator and the percentage wildcard character, and this is what we do to determine whether or not these things are true or not. It's a very slow and iterative process, but we're not going to be going through a lot of really tedious tasks. We'll be going through a few characters just to see what it's like. But yeah, let's go back to the web page. So on level 3 of the SQL injection examples machine, you're presented with a mock browser with the following URL. This is the URL. It checks a username, whether or not it is present on the database system. The browser body contains taken true. This API endpoint replicates a common feature found on many sign-up forms, which checks whether a username has already been registered to prompt the user to choose a different username. Because the taken value is set to true, we can assume the username admin is already registered. We can confirm this by changing the username in the mock browser's address bar from admin to admin123, and upon pressing enter, you see the value has now changed to false. Okay, so we can go over to our practice website over here. And what we need to do is we need to move through the first couple levels of this. Okay, so I've got the passwords written down here. So the answer to level 1 is this. So go ahead and its password with $signs instead of S's. I pasted it in the chat so you can quickly move through these levels. And the username, this level 2 is the blind SQL authorization bypass. So that's going to be this string right here. I'll copy that in the chat for you as well. Okay, maybe. Yeah. Well, you're going to. I can't paste that one in the chat because it's not it's showing me an error message when I try to paste that. But it's good. It's single quote or 1 equals 1 space dash 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 and then space. So use that along with test, and you should be on to level 3. Okay, so click on level 3, this button right here, and it will take us to where we want to be. So this is level 3, and if you see this right here, along with the taken :true, then you're on the right page. So if you're there and you're ready to start, please type boolean me, boolean you. Okay, so this endpoint right here is uses a URL parameter to check whether or not names are present on the database. So we see that admin has been taken. It's taken equals true, but if we type in admin123, then we see taken equals false. So we see that we get different results from the database depending on whether or not the name is present on the present in the database. So we can move on to the next part of this. So the SQL query that is processed looks like the following. It's going to be select star from users, where username equals username, and this is the user input right here, and it's limit 1, so it's only going to return 1 row. So the only input we have control over is the username in the query string, and we'll have to use this to perform our SQL injection. Keep the username as admin123, and we can start appending to this, try to make the database confirm true things, changing the state of the taken field from false to true. Okay, so at this point, we're going to be using, we're going to be enumerating with our union select. So let's get to that. So inside of here, all we have to do inside of this field right here is union select 1, and then we have to end the statement, and then we have to comment out everything else. So at the end of the statement, it is semicolon, and then to comment everything out, it is double dashes, and then space 1 more time. Okay? And if we select 1 column right here with the union select, we're testing to see how many columns are in the original SQL statement. And if we get the correct number of columns, then taken should become taken true instead of taken false. So let's go ahead and enumerate, starting with 1 column. Okay, so 1 column is false, so we can move on to 2 columns. So we go from union select 1 to union select 1, 2. And that is also false, and then we'll try union select 1, 2, 3. So union select 1, 2, 3. Okay, so that should have returned true. Am I forgetting something here? I might have to, let me take a look at this. Okay, so what I forgot here was that there's supposed to be a single quote right here, because single quote over here is going to encapsulate, is going to encase the username. So I need to include a single quote after admin123. So admin123 and then single quote. And now it comes back taken equals true. All right, so now we know that there are three columns in this original select statement, and we've done so by enumerating through union select. So I'm going to copy this this payload right here, and I'll include it in chat for you to try. Okay, so from there, let's go back to the walkthrough over here. So unit select 1, 2, 3. Now that our number of columns has been established, we can work on enumeration of the database. Our first task is to discover the database name. We can use this by using the built-in database method, then using the like operator to try and find results that will return a true status. Try the below username value and see what happens. So we see that this is a lot like using the database function in order to find out what the name of the database is. But in this case, we're using database, and then we're trying to find out what the name of the database is by guessing. So we're guessing different characters right here, and we're using the like wildcard character in order to keep our guesses going. So let's I'll demonstrate this inside of the app. So I'm going to copy this. And I'll paste it in chat just so you can have a reference. And then we'll go over to level 3 over here. So we're trying to find out what the name of the database is with the like operator and the percentage sign wildcard character. This is going to return true because the name of the database has something in it. So this will return with anything basically. So we'll see that this is going to return true. But what we need to do is we need to find out the name of the database by cycling through the letters in the alphabet. So A, and then we can try B, and then we can, so these keep on returning false because it doesn't start with this letter. But the letter it actually starts with is S. So if we do S, then it's true. And then what we would do is we would keep on going through S and then A, and then S and then B, and eventually we would figure out that the next letter is Q over here. So this is taken equals true. So we would do this over and over again. Eventually, we would figure out that the name of this database is SQLi_3. So this is also taken equals true. So you might ask, so after we figured out that that the name is SQL_3, how do we know that there aren't more numbers, that there aren't more characters after this? So basically, we would only know that there are no more letters after this after we've exhausted all the other possibilities. So we would go through A to Z after this, and then we would do the numbers 1, 2, 3, 4, 5 to 0, and we would try all the special characters, and eventually we would exhaust all the possibilities, and we would figure out that the name of the database is SQL_3, and that's it. So from here, let's take a look. So you discover all the characters of the database, which is SQL_3. So we've established a database name, which we can use to enumerate table names using a similar method to utilizing the information schema database. So try setting the username to the following value. Okay, so we would do this right here to enumerate what the table names are. And I've provided this in the chat. So this is, I hope you're, well, I mean, you've probably figured out by now that this is a very tedious and time-intensive task. So here we would use table name equals A something something, and then it would return false. And eventually we would come upon U, and that is taken equals true. And eventually we would iterate through all of these, and we would figure out there's a table called users, and the name equals true. So we would the next thing we would do is try to enumerate the column names inside of the user table. So let's go back here. So eventually we figure out that the database name is SQLi_3, and the table name equals users. And then we would try to figure out the columns with this payload right here. So one more time, we would have to cycle through all of the letters. And this is to figure out what the column names are. So inside of the users table, the column names are probably something like users. Okay, so maybe it's username. So taken equals true. And another one is probably password. So the column names inside of the users table are username and password. So now that we know that, we can move on to the next step, which is trying to figure out what the contents of username and password are. So we go back here. So union select from information schema.columns, where table schema equals SQLi_3 and table name equals users, and column name like something, and the column name is not ID. So this is what we do to eliminate column names that we already know the names of. So in this case, that if we already have the ID table, the ID column, we can exclude it with this filter right here. So the next step is to figure out what the username is. So select from users where username like. So this is how we figure out what the username is. And eventually we'll figure out that the username is equal to admin. So after we figured out that, the last thing to do is to figure out what the password is right here. So since the password is relatively short, let's demonstrate how this is done. So we'll paste in this payload right here. So password is like, we would go through A, B, C, D, E, F, G, all the way to Z, and then we go through the numbers. So does it start with 1? Does it start with 2? 3? It does start with 3. So after we know that it starts with 3, then we would go through all of the letters again. But in this case, we know that this password is actually a sequence of 4 numbers. So so it's 1, it's not 3, 2, is it 3? It's not 3, 3. It's not 3, 4, it's not 3, 5. 3, 7, 3, 8. So it is 3, 8. So after 3, 8, we try 3, 8, 1, 3, 8, 2. So it is 3, 8, 4. So it is 3, 8, 4, 5. So it's 3, 8, 4, 5. If we wanted to guess additional numbers after this, we could. We could guess a bunch of other numbers and a bunch of other letters, but eventually we would figure out that we've exhausted all of the other possibilities. So this is what the password is. So go ahead and try to log in to this login form using the username admin and the password of this number right here. So I'll paste this in the chat for you all to have reference to, and then click on login, and that is the end of that level. So after you log in using the username and password that you got from the Boolean injection, copy this flag right here, and this is going to be the answer for the task question at the end of the task. So copy this, and then go over to the Try Hack Me page and supply the flag that you copied as the answer to the question. Okay, so if you have any questions about SQL Boolean injection and how we enumerated the database for the names of the columns in the database and the tables, go ahead and type that in chat if there's anything that you didn't understand. I'll try to answer the questions as best I can. All right, so if you managed to finish that section right there, please type "booyah" in chat with smiley faces or frog emotes, whatever you like, just like this. Okay, so before we let's talk about the next type of blind SQLi injection that we're going to be doing today. It's time-based SQL injection. So, blind SQL injection, time-based. Time-based SQL injection is a type of blind SQL injection where we give the database software an instruction to return a delayed response. And if so, we know that the attack was successful. So this, so time-based SQL injection is even more tedious than Boolean-based SQL injection. So it's so that's why most people use automated exploitation scripts like SQL map in order to do stuff like this. Okay, so all right, Hachi says booyah. Nice to hear. All right. So, time-based Boolean SQL injection makes use of this this function right here, the sleep function. The SQL feature that is used in time-based SQL injection is the sleep function, where the number of seconds the response is delayed by is indicated in the parentheses. So in time-based SQL injection, we have to use the sleep function, and we know that our injection came back was successful if the system has a significant delay in delivering the response. So time-based SQL injection is similar to Boolean-based injection in most ways. So it is a lot like the Boolean injection that we used in the previous section, except that we're using the sleep function in addition to guessing at what the letters are in the database. So there's no visual feedback to indicate whether or not an injection string has returned true or false. There's just a delay. Rather, time-based SQL injection makes use of the SQL sleep method to delay the return of successful injection strings. So inside of this app, it handily tells you what the delay is in the response time over here. But when you're working with regular apps and testing for time-based SQL injection, you're not going to be able to see a message like this. It's just going to be a delay, and you're going to have to figure it out that way. So okay, so let's try it out. So time-based SQL blind SQL injection. Let's go over to the section on it over here. So the first thing we need to do is we need to find a true statement. So this is this right here is simulating trying to retrieve the number of columns in the union select. So I'll just paste this for reference, and we'll go over to the web app. So in this case, it's going this particular web app is trying to is telling the system what the name of the referring web page is. So the web page we just went from to arrive at this web page. And in this case, it says refer equals tryhackme.com. But instead of that, we're going to feed it a false result, which is admin123, and then we're going to close out the statement, and then we're going to union select and try to enumerate the number of columns in the statement. So in this case, we're trying to see if the union select, and then we use sleep 5 in this case. And this takes the place of one column over here. So if it's successful, that means there's one column in the original SQL statement. So we can return this. And because the request time was very quick to come back, that means that that is not correct. So we can actually go on to 2 columns from here. So sleep and then comma 2, and then try it again. And you see that there's a delay here. So it says request time is 5.002, which means that this is probably the number of columns in the SQL, in the original SQL statement that we've matched in the union select statement. So this is where we start. So let's go back to the web page. So this is the payload that we sent to it, and it says this payload should have produced a 5-second delay confirming the successful execution of the union statement and that there are 2 columns. You can now repeat the enumeration process from the Boolean-based SQL injection, adding the sleep method to the union select statement. If you're struggling to find the table name, the below query should help you on your way. Okay, so in this case, they're giving us the next step over here, which is trying to find out the database name. And I've provided this payload in the chat for everybody to have a reference. So let's try this ourselves. Okay, so this is enumerating for the name of the database. So if you remember the name of the last database, what do you think the name of this database is? So if you can guess at what the names of the database and or the tables, it's going to make this process a lot faster. So what do you think the name of the database is? Do you remember the name of the previous database? Okay, so Hachi says that the name of the previous database was SQLi_3. So based on that, what can we guess the name of this database is? So it's going to be SQLi and then underscore. And this is also level 4. So we might guess that the name of the database is SQLi_4. And that is confirmed. So the name of the database is SQLi_4. So let me grab my notes. So just for everybody's reference, I'm just going to pull up the guide document for this particular workshop. I've created a step-by-step document for completing this workshop at the address that I provided in chat. If you want to, you can use that for reference. So let me copy that. I think I could use it right about now. Okay. Let me grab the next. Okay, so I'm going to provide the next SQL injection payload that we want to try. And this is going to be enumerating for the table name. So it's going to be where table schema equals SQLi_4 and table_name like. So if we can guess at the names of the tables from the previous exercise, what can we guess the name of the table we're looking for here, what that is? So once again, we're asked to get the username and password from the SQL database and log in. So we're looking for a table name, and the table name is probably going to be users. Correct. Okay, so if we just try users over here, that is completely fine. And next we're trying to get the column names. And if you can guess what the column names are, we can kind of skip a lot of this guesswork. So inside of, so the database is SQLi_4, the table name is users, and the column names are probably going to be something like Hachi says username and password. Okay, so I think that is exactly what we're looking for. So username is going to check out. And I'll ask the next question. So the next question is, if we can guess at the username and password columns, what username are we looking for? So based on the enumeration we did in the last exercise, which username are we looking for? So just like the previous exercise, we're probably looking for the admin user. So let's skip over to the part of the exercise where we're trying to guess at the password. So I'm going to paste in the payload that we're trying to use to guess at the password. And I'll let you know that the password is a four-digit number. What I want you to try is I want you to try to get the password, the four-digit password, before I finish getting the four-digit password. So from here, and once you have the four-digit password, please type it in chat, and then we will give you kudos. Isn't that nice? So what you would do is you would start from 0, and you would start enumerating for the four-digit password. Fortunately, the request comes back immediately if it's wrong, but if it's right, then it's going to have a delay. Okay, so the first digit is 4, so we're going to try for the second digit of the password. So Hachi mentioned earlier in chat that they used SQL map inside of a Hack the Box educational module. When you're using SQL map inside of the Hack the Box module, did you find it very easy to use? And how many SQL bases did you dump using the SQL map program? Okay, so it's not 5, not 6. So if you're trying to, Hachi, if you're trying to solve this, oh, Hachi got the answer. Okay, so let's try 464961. And Hachi, if why don't you please tell us what your experience was with SQL Map inside of Hack the Box? Did you find it easy to use, or did you find it a bit difficult to get the syntax right? Because I know that when I've used SQL Map, it's kind of like fighting it, because I'm always trying to figure out which different flags to use when I'm setting up my SQL Map command. Oh, you found it pretty easy. Okay, well I'm glad to hear that. I always had a bit of a struggle when using SQL Map, maybe because I don't have as much experience with it. Okay, so let's log in to the application using the password we found. So it's going to be admin, and it's going to be 4961. So log in, and it says training complete, and the flag here is THM SQL Injection Master. So we can copy this and use this to answer the question inside of the task over here. What is the final flag after completing level 4? Hachi says there are lots of options, but the way the module is laid out points you in the right direction. Well, I'm glad to hear that, because I've used SQL Map in a number of different CTF boxes to try to dump SQL databases, and sometimes I find it a bit hard to find exactly the syntax that I need to do in order to get the database to dump its contents. Oh, one other question. So when you were using SQL Map inside of Hack the Box, were you ever able to get remote code execution using SQL Map? As in, you were able to use SQL Map to get an interactive console on the vulnerable system, like a reverse shell. Okay, so let's move on to the last section. So sorry, this is not the last section, but it's the last type of SQL injection that we're talking about. So we're talking about out-of-band SQL injection. Out-of-band SQL injection isn't as common as it either depends on specific features being enabled on the database server or the web application's business logic, which makes some kind of external network call based on the results of an SQL query. An out-of-band attack is classified as having two different communication channels, one to launch the attack and the other to gather the results. For example, an attack could be a web request, and the data gathering channel could be monitoring HTTP DNS requests made to a service you control. Okay, so an attacker. So in the example, we have a hacker, and then there's a website, and then there's a database, and we're trying to get the database to communicate with with a service that the hacker controls. So Hachi says you only have to find a flag navigating with SQL Map. Okay. All right. So actually, maybe that's what we could try. We could try getting a reverse shell by using SQL Map, because it is possible to get reverse shells using SQL Map, depending on how badly implemented the SQL injection flaw is on the web app. So let's one, an attacker makes a request to a website vulnerable to SQL injection with an injection payload. So that's number 1 over here. So the hacker attacks the website. Number 2, the website makes a SQL query to the database, which also passes the hacker's payload. So this is number 2, the website communicates with the database. And number 3, the payload contains a request which forces an HTTP request back to the hacker's machine containing data from the database. So the database will connect with a service that is under the hacker's control, and that is how we get the information from the database through the SQL injection. So I've mapped out a whole diagram over here. So we're talking about out-of-band SQL injection. I hope this makes things a bit more clear, because it took me a little while to understand what this is talking about. So the output of any SQL queries can be passed through services outside of the web apps network. So usually the database and the web app are the only things that you're seeing as the user. So this is called in-band. So in-band means inside of the web applications network. But when we're talking about out-of-band, it means that the things that are outside of the web app, the web app's domain, are involved. So I'm going to start up my music again, just a second. Okay. So for example, one example would be where SQL injection is able to trigger a DNS query lookup to an attacker-controlled server. So the SQL query output would then be included in the logs for the out-of-bound service used. So out-of-bound SQL injection is uncommon because it requires the SQL software to be able to send SQL data out of band. So here's the web app, and here's the SQL database. So this is considered in-band. So this is within the network of the web app and the SQL database. These are connected technologies. But then the SQL database has to contact something that is outside of the network, which is also called out-of-band. So that is outside of the web app's domain. So as opposed to in-band or blind SQL injection, where results of database queries can be seen inside of the web app. So the web app is going to, so this is a loop where the web app communicates with the SQL database, and the SQL database returns the data to the web app. So out-of-bound attacks require two different communication channels, one to launch the attack and another to gather the results. So the attacker's web browser and the attacker's web server, which might be contacted as part of an out-of-bound attack, are both out-of-bound resources. So the vulnerable web app and the vulnerable database are in one band, and the attacker's web server and the attacker's web browser are in another band. So in a typical out-of-band attack, the attacker injects SQL queries to the SQL database via the web app. So the attacker's web browser communicates with the web app, and then to the SQL database, and then it goes back to the web app, and then back to the attacker's web browser. So the database sends the output of the SQL injection via HTTP DNS traffic to the attacker's web server. So this is an example of the out-of-bound attack. So the attacker web browser communicates with the web app, which communicates with the SQL database, and we find some way to have the SQL database contact the attacker's web server, which is going to log the information provided by the SQL database. So unfortunately, we can't illustrate out-of-bound SQL attacks with the technology we have right here, but it is out-of-bound SQL attacks can be performed using Burp Suite, but not just the community version of Burp Suite, but the pro version of Burp Suite, which lets you set up attacker-controlled servers, which the SQL database is going to contact. So that's kind of it doesn't feel too great that we have to use a paid product in order to test this stuff, but it is possible to test out-of-bound stuff with free resources. It's just a little bit trickier, and I haven't been doing too much research into how to do that. So the attacker-controlled web server is going to receive and log the results and can be retrieved by the attacker at their leisure. Okay, so the last thing we need to learn about SQL injection is how to stop it. So this is called remediation. So before that, let's go over to here and the question. So name a protocol beginning with D that can be used to exfiltrate data from the database. So if inside of here, there's a service that starts with D and has 3 letters, that is the answer to this question. What do you think it is? If you know, type it in chat. Okay, so the answer is DNS. Hachi answered the question correctly. Thank you very much, Hachi. Okay, so the name of the protocol is DNS. Okay, so let's go over the last section over here. So we're talking about remediation. So it says here there are a few different ways to remediate against SQL injection vulnerabilities. Developers have a way to protect their web applications by following the advice below. Okay, so there are prepared statements with parameterized queries. In a prepared query, the first thing a developer writes is a SQL query, and then any user inputs are added as parameters afterwards. Writing prepared statements ensures that the SQL code structure doesn't change, and the database can distinguish between query and data. As a benefit, it also makes your code look cleaner and easier to read. So the second method is input validation. Input validation can go a long way to protecting what gets put into a SQL query. Employing an allow list can restrict input to only certain strings, or a string replacement method in the programming language can filter the characters you wish to allow or disallow. Okay, so input validation is basically making sure that the user input doesn't only include certain characters or doesn't include characters, which are usually characters that are associated with SQL injection. And the last thing is escaping user input. Allowing user input containing the characters such as these characters right here can cause SQL queries to break, or even worse, as we learned, open them up for injection attacks. So escaping user input is as a method of prepending a backslash to these characters, which causes them to be parsed just as regular strings and not a special character. So in short, I prepared another little section over here. Okay. So the first method is prepared statements with parameterized queries. So here we're isolating the SQL query and the input that the user is providing. So these things are separated from each other and the user input can't be interpreted as a part of the SQL command. So here we're separating the queries. So the SQL query is select from users where username equals username and password. So this is the parameterized query, which is this is where the parameterized query would go, and this is the prepared statement. So in addition, the queries are parameterized, which further serves to isolate user inputs from SQL statements. So we're basically turning everything into a variable, where the variables don't really interact with each other, and this is how we protect against SQL injection. So the next one is input validation, so which filters or modifies user input that includes special characters. So over here, there's a function where we sanitize the input, and so it basically scans the input for any of these special characters, or this one over here, which creates a command shell, which is another big no-no. So special characters and user input are what enables SQL injection attacks, and input validation helps in securing web apps. So the last thing is escaping user input. So the final method is escaping user input, which also targets special characters and user input. So basically, if it sees any of these special characters in the user input, it's going to modify those characters so that they appear as the string version of those characters and not the special character version of those characters. The escaped user input modifies special characters in such a way that SQL software will not interpret these characters as code. So let's very quickly go over what we learned in today's workshop. So blind SQL injection, Boolean-based, is a type of blind SQL injection where the only input that is returned after a SQL statement is whether the query returned true or false. Blind SQL injection that is time-based is a type of blind SQL injection where we give the database software an instruction to return a delayed response, and if so, we know that the attack was successful. Out-of-band SQL injection is a type of SQL injection where the output of any SQL queries can be passed to services outside of the web apps network. And lastly, we learned about how to remediate web apps against SQL injection vulnerability, with practices such as prepared statements with parameterized queries, input validation, and escaping user input. So in the next HackerFrogs After School Web App Hacking Workshop, we'll be learning how to use Burp Suite, the industry standard software for web app security testing. So while I still have you here, if you are from the Black Girls Hack organization, please take some time to fill out the survey over here that they're having me pass out with every workshop, just to let them know that I'm doing a good job. And if you think that I'm not doing a good job, let them know that I'm not doing a good job. Either way, I want to improve on my teaching and the materials that I'm putting into the workshops to help you learn. Okay, so what are we going to be doing for our streams this week? So this is where the HackerFrogs Reddit group comes in, and I'll leave that as a link over here. So we are in week 15. So today we're doing the HackerFrogs After School SQL Injection Part 2, which we just finished. But on Wednesday, we're going to do extra credit. We're going to be doing SQL injection exercises, Boolean and time-based. And it's going to be at the same time, but on Wednesday. So we're either going to be working with the SQL map module from TryHackMe, or we're going to be trying to use SQL map to solve the blind SQL injection exercises from the DBWA module from TryHackMe. And then on Friday, we're going to be doing a short finale of the PicoCTF challenges that are going to be at the intermediate level. There's only a few challenges left that I'm going to be going over. But if you were ever interested in going over any of the PicoCTF challenges from this year, then yeah, it would be fun to go over them with you all. At this point, I'd like to remind you that I've been doing a series of different PicoCTF challenges inside of this playlist over here, PicoCTF 2024. I'll leave that in the chat for everybody. So yeah, so if you want to go over each one of these challenges in a bite-sized format, so the longest one is under 10 minutes long. So if you wanted to go work along with the challenges in this playlist, that'd be great. Victoria OR is now a HackerFrog. Welcome, Victoria. I hope you've had fun in today's workshop. And yeah, if you wanted to catch what we were doing before, you can always go back in the YouTube live video, and it's going to be published both to Twitch and YouTube after this is over. But yeah, so everybody who participated today, to Hachi and to Ilhan Idris and to Victoria OR, thank you very much for coming, and yeah, we'll see you next time. Have a great week, everybody.